All right, we are going to be solving another question on shear force and bending moment diagram. So above is the question. We are going to be drawing the shear force and bending moment diagram, but we are going to be using sectioning method or method of sectioning. All right, so we know if you are using any method to draw a bending moment and shear force diagram, you must always calculate first the reaction at the support. So let's do that. All right, so the first thing we are going to do is to take the summation of our vertical forces to be equals to what? 0. And then we are taking upward force positive and downward force negative. All right, so we're going to have reaction at A plus our reaction at B, because they are both upward and upward force is positive. So this will be equal to the sum of the downward force, which is 2 plus 2, which is what? 4. So if we make our reaction at A the subject, our reaction at A will be equals to 4 minus reaction at B. So we can call this our equation number 1. So the next thing we are going to do is to take the summation of moment about point A. So the summation of moment about point A should be equals to 0. Again, upward force positive, downward force negative. The moment produced by our upward force is positive, the moment produced by our downward force is negative. Our upward force, if we stand at this point, we are taking our moment towards this side. We know moment is force times perpendicular distance. This is the force and perpendicular distance to this point. Force, perpendicular distance, force, perpendicular distance. So our upward force there is RB, so we are going to have RB multiplied by what? The total distance here is 9. Then minus 2 multiplied by the total distance here is 6. Then minus 2, the total distance is 3. So everything will be equals to 0. All right. So here we are going to have 9 RB. Then minus this will be equals to minus 12 minus 9. 9 plus 12, that is 18. If we move minus 18 to the other side, it's going to be what? Positive 18. So we divide both sides by 9, and means that this will go with this. Then our RB will be equals to 2 kilonewton. All right. So it means that our reaction at A will also be equals to 4 minus reaction at B, that is 4 minus 2, which is also 2 kilonewton. All right, so that is it. Now we are going to start with the sectioning method now. So for us to apply method of sectioning or sectioning method, we are going to be first, you must first know how many sections are you going to need to solve the question completely, since we are drawing shear force and bending moment diagram. All right, so now the first thing you are going to observe is between this point and this point we have a downward force. Between this point and this point we have a downward force. Between this point and this point we have let's say this upward force here. Now what we are going to do is we are going to section between the forces. Do you understand? So it means between this point and this point we have one section. Between this one and this one we have another section. Between this point and this point we have another section. So it means we need 3 sections to solve the question completely. All right, so the first section now, we are going to section point, we are going to consider section SS between beam AC. All right, so let's call this at a distance of S. At distance of S. All right, so at distance of S. All right, so let's take our section SS. So now we are now going to draw this part now that we have cut out of this beam. Now we are going to draw it here. So we are considering beam. All right, so this is what we have. All right, So now if we section a beam, next thing you are going to notice, once you have bring out the section part here, now you are going to note that the beam is going to have what? The beam is going to have a moment, is going to have a shear force, and it's going to have an horizontal force. But in this case now, since we don't have any horizontal force on the beam, so we are not going to consider horizontal force. So we are only going to consider moment and shear force. All right. So we are going to have moment in this direction, which is moment about S. All right. So moment about S. Then the next thing we are going to do is to draw the diagram for our shear force. All right. So this is it. Now, the next thing we are going to do now is we are going to take the summation of moments about the section part SS to be equals to 0. This condition is still the same. Upward force is positive, downward force is negative. All right. So, and the moment produced by the upward force here is still positive, and the moment produced by downward force will be also what? Negative. All right. So now if you look at this upward force here, taking the moment towards this side, we are going to have ROAS, because ROA multiplied by total distance, that is RAS, and this moment is going against the moment produced here. You can see this moment is going clockwise while this one is going anti-clockwise. So we are going to have minus m subscript s to be equals to what? 0. So if we make m subscript our moment here along the section, the subject, we are going to have ms to be equals to what? RAS, and then we already know the value of our reaction at A, which is what? 2. So we are going to say our ms will be equals to 2s. All right, so this will be the moment. All right, so now the next thing is this. We are going to get this shear force, but how are we going to get the shear force? We are going to note carefully that we are going, if you differentiate the equation of our moment, we are going to get our what? Shear force. And if you integrate the equation of our shear force, you are going to get what? Our moment. I hope you understand. All right, so now we are going to say shear force is equals to D over ds of the moment along the sectioning part, which is going to be D over ds of what? Of 2s. So if you differentiate 2s, I'm going to have your V to be equals to 2 kilonewton. All right. So we are done with that part. The value of shear force there is 2 kilonewton. So the next thing we are going to consider is beam AD. So beam A. All right, beam AD. All right. So if you section this part now, all right. So we have S. So we can call at a distance of S1. All right, so let's this be at a distance of S1. All right, S1. So if we draw, if we our downward force here is 2 kilonewton. All right. So if from this point to this point is 3 meters, and from this point to this point is S1, the distance here is going to be S1 minus 3. So we are going to have S1 minus 3 here. So the distance from this point to this point is going to be S1 minus 3. Sorry for that. Just love my work to be neat. All right. So, all right. All right. So now, once you section it again, we are going to have moment. And then we are going to have shear force. All right. All right. So that's it. So again, we are going to consider moment. summation of moment along the section path to be equals to 0. All right. So again, upward force positive, downward force negative. The moment produced by the upward force is positive. The moment produced by the downward force is what? Negative. Don't change this. Students do complicate things. Yeah, by the time they start changing moment and this and that, please just stick to it. You get that? All right. So we are taking our moment towards this part. So it's going to be RA multiplied by what? S1, because it is upward force. This reaction at A multiplied by S1. All right, so minus, because it's a downward force, 2 multiplied by the distance. The distance from this point to this point is S1 minus 3. So it's going to be minus 2 into S1 minus 3. So again, we are having a moment. This moment here will always be going in the same direction with the downward force. So it's all going to be minus what? Minus ms equals to what? 0. All right. So if we make our moment here the subject, so if we take it to the other side, it means moments here will be equals to RA S1 minus 2 into S1 minus 3. All right, so this will be equals to, what is our ROA? Our ROA is 2. So we are going to have 2S1 minus, if you clear the bracket, you have 2S1 plus 6. So this will be equals to what? This will be equals to 2S1, we cancel out 2S1, then we'll be left with 6. So the moment here is 6. So it shows that our moment here is going to be 6 kilonewton meter. So yeah, we are going to find our shear force. Shear force is D over ds of M subscript S, so which is going to be equals to D over ds of 6. So we differentiate 6. 6 is just like a constant. This is going to be 0 kilonewton. So it shows that the value of shear force is 0, right? All right, so we are done with that as well. So the next thing we are going to do here is to take the section of, so consider beam DB rather. So we are going to section this part. All right. So this is going to be at a distance of, S2. All right. All right. So something like that. All right. So if you now bring out the sectioning part, you are going to all right. So if the total distance is S2 and from here to here is 3, from here to here is 3, so it means this place is going to be S2 minus 6. So we are going to have here to be S2 minus 6. All right. Let me write this properly. So we are going to have here to be S2 minus 6. All right. I think it is more clearer that way. All right. All right. So I think everything is ready now. So yeah, we're going to have moment. So moment about S, and then we are going to have shear force. All right. All right. So that's it. Now we are going to be taking our moment towards the sectioning part. So we are going to have moment along the section part SS to be equals to what? 0. So if we do that, RA multiplied by total distance is going to be reaction at A S2 Then if we do this, it's going to be minus 2 multiplied by the total distance, minus 2 into minus 2 into 3 plus s2 minus 6. Then this one here is going to be minus 2 multiplied by s2 minus 6. Then if you consider this moment here, it's always going the same direction with the downward force, so it's going to be minus m subscript s, everything equals to 0. All right, so now if we move this ms to the other side, so we are going to rewrite this equation as ms to be equals to reaction at A multiplied by S2. So here, okay, let me just first rewrite everything that we have here. Minus 2 into 3 minus 6 is minus 3. So we can rewrite this as S2 minus 3. Then here we are going to have minus 2 into S2 minus 6. All right. So we can therefore make our substitution now. So we know that our reaction at A is 2. All right. So this is going to be 2S2. It's going to be plus 6. It's going to be minus 2S2 and plus 12. Plus 12. All right. So this will go with this. Then 6 plus this is going to give us 18. So we are going to have subscript s, that is the moment along that section, to be what? To be 12, or let's say minus 2s plus 12. All right, so that will be the equation of the moment along that section. All right, so now we can get our shear force now. So our shear force is D all over what? ds into ms, so which is going to be D into ds into minus 2s2 plus 12. All right, so if you differentiate that, our V will be equals to what? Our V will be equals to minus 2 kilonewton. All right, so that is what we are going to have. All right, so now the next thing is we are going to be using the information above to draw the shear force and bending moment diagram. So, and you know, according to the rule, the shear force diagram and the bending moment diagram must be under the beam. So we are going to need to clean this part. We don't need any information here again. So this is the information, the moment and the moment equation, and the value of our shear force is what we are going to use to plot the graph. All right, so let's draw the shear force and the bending moment diagram. All right, so you have to pay attention here. All right, so for us to draw the shear force and bending moment diagram, the line here is the reference line for our shear force. The line here is the reference line for our bending moment. And above and below both lines, above is positive, below is negative. Above is positive, below is negative. All right. Now, what you are going to note here is this. Here we are starting with the shear force first. Now, if you want to find your shear force at point A and point C, we are going to be using the beam AC to do that. And after that, the point you need to get now is point D. And if you want to get the shear force at point D, you just go to the beam AD and use beam AD to analyze that. Then if you want to get your point, your shear force at point B, you now use beam DB to analyze that. I hope you understand. All right, let's start now. So now, I want to get shear force at point at point A. Now, if you go to point A, to go to beam AC, we already have the shear force value there to be what? 2 kilonewton. Is that clear? Which is positive, right? So it means we know from this point here is 0. This point here is 0. So from 0 now we are moving up, positive, which is 2. So now let's just take a point here. Let's take this point here to be let's take this point here to be 2. All right, so what are we going to do next? We are going to join the point with the 0 line. All right, so the next thing is you are going to consider between A and C. Do we have any line here? No. So it means there's going to be a constant line here. So you are going to draw a constant line from this point to this point. All right, so now the next question you are going to ask yourself is this. Now we are having a downward force here. Please take note. We are having a downward force here. So now, and then we know that from this point to this point is 2, right? So we are going to subtract 2 from 2. You understand? So 2 minus 2 is what? 0. It means this force, this diagram is going to go back to 0 like that, because this point here is 0. So you are going to draw a line here. And this line is going to be 0. All right, and if you check again, from this point to this point, we don't have any force. We don't have any force. So it means it's going to be there's going to be a constant line here up to this point, right? All right, so 0. Don't forget 0. So now again, we are having a downward force, right? So we are going to say we are going to subtract 2 from 0. So it's going to be 0 minus 2, which is going to give us what? Minus 2. It means we are going to go down to the negative part, which is minus 2. So let's take this point here to be our minus 2. So it means we are going to join this line here. All right, so minus 2. So between D and B, we don't have any force. So there's going to be a constant line here. And the diagram will go back to 0. All right. So and it's going to go back to 0. All right, so that's it. So you can shade now. All right, so that's it. So this point is positive, while this point is negative. All right, so that's it. We are done with the shear force diagram. All right, and for the purpose of exam, you can write 2 here, 0 here. That is 2, 2, 0, 0. Then negative 2, negative 2, like that. Then 0. All right, so that's it. All right, so now let's go for the bending moment now. All right, so let's go for the bending moment. So for us to get the bending moment at point A, we are going to go to the equation of the equation for the bending moment equation in diagram AC, and this is the moment. The moment here is equals to 2s, right? All right, so and at point A, our point A is at a distance of what? 0. Our point C is at a distance of what? 3. Our point D is at a distance of what? It's at a distance of 6. Our point B is at a distance of what? It's at a distance of 9. So for us to get the moment at point A, we are going to go to the bending moment equation between beam AC, and then we are going to substitute for the value of S, and then we are going to get our moment. For us to get the bending moment at point C, we are going to take note of the distance of S there. Our point C is at distance 3. So it means that our S there is going to be what? 3. So we are going to get our moment. So for us to get the moment at point D, point D is at a distance of 6. Means we are going to substitute. We are going to go to beam AD. We are going to go to the moment equation there, and you are going to see that our moment is already given to us as what? As 6 at that point there. So it shows that at point D we are going to have 6, right? So and so on and so forth. Exactly. All right. So let's start. So at point A now, let's go to this moment. We said I just told you that point A here now is at distance 0. So this is going to be 0 multiplied by 2 is what? 0. So it shows that our moment here is going to be 0. All right. So that is it. So now at point C, we are going to substitute. Our S is at point distance 3. So it's going to be 2 times 3, which is what? 6. So this is going to be 6. So let's just from 0 to 6. Let's take this point to be our 6. So we are going to be using an incliner to join this point and this point because we have a constant line here. So we are going to have alright, so that's it. Alright. So now let's find the moment at point D. So the point D is at distance 6. So let's go to the moment equation. You can see the moment there is what? 6. So it means that from this point to this point will also be 6. So since this one is 6, so it shows that it's constant there, right? Because you know that from this point to this point is also 6. So let's just draw a straight line here because it is constant. So we have 6 here and then we have 6 here. If you look at this point here, we don't have any shear force, right? So the point that we don't have shear force, there will be a constant moment. Exactly. So that is what is going on there. Alright. So now the next point here is our bending moment at point B, which is S is 9. So we are going to go to the moment equation at beam DB. So this is the moment equation, right? So if we put 9 here, what do we have? So we are going to have I'm coming. So I say, okay, I made a mistake here. Sorry, please. 6 plus 12 is 18, not 12. Sorry. Alright, so our S2 there is at distance 9. So it's going to be 9 times minus 2 is what? Minus 18. Minus 18 plus 18 is what? 0. So here we are going to have 0. So it shows that the we are going to draw an inclined line from this point to join this point together as well. So since we are having a constant line there, we are going to have an inclined line here. Alright. So again, you can just shade your diagram. Who might be in need of them. Alright, so this is, and you see we don't have point of contraflare, right? Because we know point of contraflare is a point whereby our bending moment diagram changes in sign, either from positive to negative or from negative to positive. So all of this stuff is positive throughout. Alright, so this is how to go about the question, and I believe we understand this carefully. So if today is your first time of coming across our content, do well to click on the subscribe button and do well to click on the notification bell so that anytime we upload a video like this, you'll be the first to receive the notification, and do well to join our membership group where you are going to have access to more premium content like the one you are watching. And please don't forget to don't forget to give this video a thumbs up, and don't forget to drop a comment and tell us how well you understood what you just learned. And if you have any question, drop in the comment section. We are going to reply to you immediately. And please share this content to your friends in various departments. Peace out.